and we are the League of the Outstanding Chemistry Teachers, and we are about to discuss our topic today. Yes, Vanee, since we are done with the properties of substances, let's move on to our next topic for this day's episode.
You're right, Aya, and for our topic today, we will discuss the exist and the limiting reactants.
Listen carefully so that you will understand it easily.
Good afternoon, students. I am April, and I will tackle about stoichiometry. Stoichiometry is the calculation of relative quantities of reactants and products in chemical reactions. Stoichiometry is founded in the law of conservation of mass, where the total mass of the reactants is equal to the total mass of the product, leading to the insight that the relations among quantities of reactants and products typically form a ratio of positive integers. This means that if the amounts of the separate reactants are known, then the amount of the product can be calculated. Conversely, if one reactant has a known quantity and the quantity of product can be empirically determined, then the amount of the other reactants can also be calculated.
Hi students, I am Steph, and I'll explain to you what is reaction stoichiometry. Reaction stoichiometry is the description of the quantitative relationships among substances as they participate in chemical reactions.
Hi students, I am Jundie, and I will explain to you what is gas stoichiometry. Gas stoichiometry deals with reactions involving gases where the gases are at a known temperature, pressure, and volume and can be assumed to be ideal gases.
Hi students, I am Brenda, and I will explain to you what is the composition stoichiometry. Composition stoichiometry describes the quantitative mass relationship among elements in compounds.
Hi students, I am Jiff, and I will explain to you what is the chemical reaction equation and the use of this equation so that you will know how to compute the limiting and excess reactants or reagents. Chemical reaction equations is used in this kind of problems to get the exact results for us to be guided. Based from the equation, we can get the right amount of reactants required to combine for a complete reaction with excess and limiting reactants.
Hello everybody, I'm Allyn Aclo, so I'm here in front of you to tackle about the limiting and excess reactants. To cite some practical examples to explain and demonstrate the limiting and excess reactants, let's have some sort of analogies to way better understand its concept in real-life situations that we sometimes encounter. Assuming that you are planning to give chocolates to some selected students of NESP as a reward of the excellent performance they make. If there are 5 students who will receive the award and 8 pieces of chocolates to be given to the students, how was it differ to the limiting and excess of reactants? So let me present to you the 5 chosen students and the 8 pieces of chocolate. So if I will give to them each chocolate, the limiting reactants would be the students, since the matter that is being used stop when it's completely consumed. And the leftover or the remains of the chocolates would be the exist, since there are 8 pieces of chocolates and only 5 of it are needed to give to the students. So the remaining 3 pieces of chocolates are the excess. So in summation, in the language of chemistry, the limiting reactants are the students and the excess are the chocolates.
At this moment, we'll try to demonstrate limiting and excess reactants by using my favorite samples, vinegar and baking soda. So we have here 4 samples of vinegar with the same amounts. This is test tube A, B, C, and D. We have also here baking soda samples with varying amounts from 2 grams, 4 grams, 6 grams and 8 grams. Let's now try to combine the two samples of reactants, the baking soda and sample B with the test tube B. So after waiting a couple of minutes, let's now examine our samples. So let's try to look at test tube A. You can see here that it is very transparent. Test tube B, it is also transparent. Test tube C, you can see here a white precipitation at the bottom of the test tube. And test tube D, same as the test tube C, but only that it has more white precipitation. Now let's try to examine each of these samples, whether it has an excess or limiting reactants, by using our ultimate test tool, the litmus paper, which will determine if the sample is acidic or basic. Now if the sample is acidic, it means that there is an excess vinegar. However, if the sample is basic, then it means that there is more or excess baking soda than the vinegar. So let's try to use litmus paper. If it turns red, it means that it's acid or acidic. If it turns blue, then it is basic. So let's try test tube A. So you can see here, the litmus paper turns pinkish or red. This means that this sample is acidic, or it has more vinegar present in this sample. So this means that this sample has an excess of vinegar, and the limiting reactant now is the baking soda. So the excess reactants is the vinegar, and the limiting reactant is the baking soda. Now let's try to examine sample B, whether it is acidic or basic. So as you can see here, there's nothing happened to the litmus paper. It is still the color of the litmus paper, so it means that this sample is neutral. It is not basic, nor it is acidic. So that means if the sample is neutral, it means that there is no excess nor limiting reactants. Both the reactants are consumed completely. That is why there is no excess and there is no limiting reactants. Now let's proceed to test tube A, or sample A. Let's try to examine whether it is basic or acidic. So as you can see here, the litmus paper turns blue or violet in color. So this means that this sample is basic, and it further means that there is more baking soda in here. There is an excess of baking soda rather than the vinegar. So this sample has an excess of baking soda, unlike the sample A, which has more or excess of vinegar. Now the last sample we have to examine is sample D. So as you can see here, there are more white substances that subsides at the bottom. So let's try if it is basic or acidic. And obviously it is basic, I think. So I guess right, the sample is basic. The lettuce paper turns violet or bluish violet. So this means that there is also an excess of baking soda than the vinegar. So in here, the excess reactants is the baking soda, while the limiting reactant is the vinegar.